So here's our second day on 4.4 day 2 on negative exponent properties here in 930 unit 4. So yesterday we learned what a negative exponent does, how it moves the base. If it was on the top, it moves it to the bottom. If it was on the bottom, it moves it to the top. Or you can think reciprocal, right? Negative exponent really means the reciprocal. So today we're going to take that idea and keep building on it and get into some more complicated problems that kind of combine all of your properties so far, but really focus on those negative exponents as well. So here's a little warm up just to think back to what we were talking about yesterday, right? A very common mistake with negative exponents. So pause your video and see if you can find the error. So the error on this one is an easy one to miss, and it happens a lot, but be careful, right? I do see that I have a negative exponent, a negative 2 exponent here, but the base is x. What is the exponent on the 3? The exponent on the 3 is that invisible positive 1, right? The negative 2 exponent only goes to the x, not both of those things. Those are two separate bases. So the base of 3 has an exponent of positive 1, so it should not be down at the bottom. It shouldn't have moved off of the top, right? All of this is on the top. That positive 3 should really be staying put right up there on the top, not moving down to the bottom. So the really correct answer should be 3 over x squared, because that 3 should have stayed put on the top and not moved. The only thing to move is the base of x that moved to the bottom, and then that exponent became positive. So just remember, be careful, right? Those negative exponents only go with the base they're attached to. Unless there's parentheses, it doesn't go with everything. All right. So we're going to get into some more complicated problems today. So just as a reminder, when we say that our answer is finished, completely simplified, right, we should not have any negative exponents left. And each variable should only appear once. If you have more than one x or more than one y, you're not done yet. Should never have a power to a power, so no parentheses left over. And then all fractions should be in simplest form. So watch those coefficients as well. All right, so here we go. Let's do a little practice now, thinking about what we've done yesterday and all of the other days. So here we go on number 1. 2a squared b to the third c to the negative fifth over 10a to the negative third. All right, now you could tackle these in a lot of different ways. Remember, we talked about this yesterday. Honestly, what I like to do that I highly recommend is I like to move anything with a negative exponent first when I have a big fraction like this. I don't try to subtract with negatives. I get goofed up every time. I want to make sure that all of my exponents are positive and then start combining what I can combine. So I see that I have an a to the negative third on the bottom. That needs to move up to the top. And I see that I have a c to the negative fifth up at the top. And it means I'm going to move down to the bottom. For right now, I'm just going to leave everything else where it is. So I'll have 2a squared b to the third staying put on the top because there's no negative exponents on those. And I'll have a 10 staying put down at the bottom. There's not a negative exponent on that one either. The a to the third is going to move up to the top. And notice my exponent will become positive once I move it. And my c to the fifth is going to move down to the bottom. And my exponent will become positive down there. Now I'm going to go through and see what I can combine and things like that. So here I see I have my coefficients out front, 2 over 10. I can divide those, right? Or think of that as a fraction, 2/10. How would you reduce that fraction, right? So if I think about that, let's see, I'm going to get my fraction set up here. 2/10 would really be 1/5, right? Or 10 divided by 2 is 5, and the bigger number is on the bottom. So my 5 is going to go down there on the bottom. You can write the 1 on the top if you want to, but you don't have to because there's going to be other things there. All right, I see that I have a like base on the top. I have a squared times a to the third. Those are both on the same level. I'm multiplying like bases, so I'm going to add my exponents. So that's going to become a to the fifth. Looks like the other two bases don't have anything to combine with. I have a b to the third on the top and a c to the fifth on the bottom, so they're just going to stay where they are, just how they are. So I'll have a to the fifth, b to the third on the top over 5c to the fifth. So if you just take it step by step, things that look complicated at the beginning are not so difficult. You'll be okay. All right. Number 2, 3yz squared, all raised to the negative second power. Now notice, this has parentheses around it. So everything in those parentheses are going to get that negative second power. Now we learned 2 different ways to do these yesterday, right? We talked about we could just distribute our exponent right away. I get 3 to the negative second. Whoops, excuse me, sorry, there we go. I get y to the negative second, and then I get z to the power to a power here. I'm going to multiply those exponents, so I get z to the negative fourth. All right, now this is all technically on the top of the fraction, right? So since every single one of these has a negative exponent, all 3 of them are going to move down to the bottom of the fraction. So it's going to become 1 over 3 to the second, y to the second, z to the fourth. And then my last step here is I see that I have a numerical base, 3 to the second power. That's going to become 9. So my final answer will be 1 over 9 y squared z to the fourth. So that's just like our regular old power outside of parentheses, multiplying inside, distribute to every base, right? And then deal with the negatives. Yesterday, though, we did talk about, I'm just going to copy the problem again, same problem. We talked about how we could see that I have a negative exponent outside to start with, and just think of this as I want to take the reciprocal to get rid of that negative exponent. So that means inside those parentheses, I'm going to have 1 over 3yz squared, right? And now my exponent is going to be positive 2. But now I've taken care of that negative exponent already. It's done and nothing else to worry about with that. So now I just take and distribute my exponent to every base inside. So I could say, okay, 1 squared on the top gives me 1. I'll have 3 squared on the bottom. I do recommend that you write that numerical base with the exponent so that you don't accidentally do 3 times 2. It's 3 to the second power, right? And then I'd have y squared on the bottom. And then I would have z to the fourth on the bottom. And then I take it one more step here, and I just take care of that numerical base. So I have 1 over 9y squared z to the fourth. Same answer, right? Whatever makes sense to you, it's perfectly fine to do it either way. I just wanted to remind you that we had 2 ways to do it yesterday, and whichever way makes sense to you, you can do that, and it's perfectly acceptable and correct. All right, let's look at number 3 here. Negative 3 to the second times negative 3 to the fourth times negative 3 to the negative third power. Now, it's a little tricky to see it, but I see that all of these are the same base, right? I'm multiplying like bases. Now, we talked yesterday, you could move that negative 3 to the negative third down to the bottom, but honestly, I think I am just going to add them all up because maybe I won't end up with a negative exponent at all. So I'm just going to take my 3 exponents here, and I'm going to add them together. So my base stays the same, so I have negative 3, and let's see, I have 2 plus 4 is 6, minus 3 is positive 3. 2 plus 4 plus negative 3 gives me an exponent of 3. And now I don't have to move anything at all. Now remember, this is a numerical base. Negative 3 to the third power. We talked about this a long time ago, but it's a good refresher here, right? If I have an odd exponent, right? I have an odd number of negatives. That means my answer is going to be negative. And then I have 3 to the third. 3 to the third is 3 times 3 is 9 times 3 is 27. So my answer should be negative 27. So just don't forget how to do those negative bases, right? But also just keep that in mind. If you have a whole string of like bases and 1 or 2 of them are negatives, maybe you want to add them up first and then see if you have to move anything, because maybe you won't have to at all. All right, number 4. 2x to the negative second, y, all raised to the second power, times x to the third, y to the negative fourth. Again, more than one way that you could do this. We could move our negative exponents first and then distribute, or we could distribute right away and then figure out if I have any negatives. Personally, I usually like to distribute first, so I think I'm going to go for that. So I'll have 2 to the second power. I will have x to the negative fourth power. Watch those negatives, right? Negative 2 times 2, negative fourth. And then I will have y to the second here. Now I notice there's no exponent outside my parentheses on the second one, so I'm just going to rewrite these without a parentheses so that I don't get myself confused and try to distribute something there. But those second ones aren't actually changing. I'm just writing it without the parentheses. All right, again, a couple of different ways you could go with this. You could move your negative exponents next, but since they're all on the same level right now, I think maybe I'm just going to combine my like bases and see if I end up with any negative exponents. First of all, I see a numerical base, so let's see, 2 to the second power will give me 4. Oops, I should put an equal sign in here. Sorry, there we go. All right, so 2 to the second power is 4. Then I see I have an x to the negative fourth and an x to the third. Let's see, negative 4 plus 3 gives me x to the negative first power. Then I have a y to the second and a y to the negative fourth. 2 plus negative 4 gives me y to the negative second. So I do have some negative exponents now that I am going to have to take care of, but that's okay. So remember, all of this is over 1. Now be careful. The exponent on the 4, this is that invisible positive 1. So that 4 is not going to move. It's going to stay on the top of the fraction. But I do have x to the negative first, which is going to have to move down to the bottom, and it'll become x to the first, or just x. And I also have y to the negative second, which is going to have to move down to the bottom, which will become y to the second. So my final answer here will be 4 over xy squared. Be careful of that invisible positive 1 on that 4 coefficient. There's your common mistake, just like our warm-up. All right, last one for you. If you can handle those, we're ready to handle this one. And if you can do this one, you can do anything. All right, so 3x to the fourth, y to the negative second over xy to the third. All raised to the negative second power. Lots going on here. Again, you could do this many, many ways, but when I have a fraction, a big fraction like that, inside parentheses, I always simplify that fraction as much as I can before I start distributing, because if you distribute that to all 5 bases right now, the odds that you make a tiny little mistake somewhere are pretty high. But if we could narrow it down to having less bases inside, the likelihood of us making a mistake is going to go down a lot. So let's do that. So let's see. First of all, I see that I have a negative exponent up there in my numerator. So I'm going to move this y to the negative second. I'm going to move it down to the bottom. But I'm seeing that everything else has a positive exponent. That's the only thing that's going to move. So I'm going to leave everything else exactly how it is. 3x to the fourth on the top, staying put. Xy to the third on the bottom, staying put. I'm going to move my y squared down to the bottom. Okay. And again, I'm just going to keep trying to simplify here. So my parentheses with my negative second power outside is staying how it is. Looks like my coefficient of 3 doesn't have any buddies here, so it's going to stay how it is. But I do have an x to the fourth on the top and an x to the first on the bottom. So let's see, if I subtract my exponents, 4 minus 1 is 3, so I'll have x to the third left. I see my bigger exponent was up top, so I will have x to the third left on top. Okay, now I see that I have some like bases down here at the bottom, y to the third times y to the second, all on the same level, multiplying like bases here, so I'm just going to add my exponents and I get y to the fifth down on the bottom. Now, that's way easier, right, to take care of. So again, at this point, you can go 2 different ways. You can just distribute that negative 2 exponent and then deal with our negatives later. Or we could think, oh, it's a negative exponent. I'm going to flip the whole thing around, reciprocal, and then distribute after that. I think on this one, I'm going to flip it the whole thing first, reciprocal. make it just a positive exponent and then deal with it after that. So that means that inside my parentheses here, it's going to become y to the 5th on the top and 3x to the 3rd on the bottom. And now my exponent is just a positive 2. Then I'm going to distribute this exponent of positive 2 to every base inside. So this becomes y to the 10th, power to a power I multiply, over. Down at the bottom, I get 3 to the 2nd power, and I get x to the 6th power, right? Power to a power, I'm going to multiply on that one. All right, only one step left to do, and that is take care of my numerical base. So my final answer will be y to the 10th over 9x to the 6th. Now again, on that one, you could have distributed your negative 2, 3 to the negative 2nd, x to the negative 6th, y to the negative 10th down at the bottom. And then all three of those exponents would be negative, so you would move them all and you'd end up right back here. And then taking care of your 3 to the 2nd power, you get the same answer. So either way that you did that would be perfectly fine. I don't think one is necessarily shorter than the other. It's just whichever way makes sense to you. All right, if you can do that problem, you can do anything. So now it's time for you to try on your own. Just remember, all the exponent rules apply right now, and you're never finished until you have all positive exponents. You should only have one of each type of base, and your fractions should always be simplified. We didn't really hit the 0 exponent, but it could show up on you. Just don't forget, anything to the 0 power is 1. When it's in those big fractions, that means you can just cancel it out. All right, good luck.